if x is an even integer and this thing, then which of the following are possible values of x indicate all such values? Well, this is what you call a compound inequality. What it really means is that what's in the middle is between this and this. It's like this is the smallest thing in the expression, this is the greatest thing, and this thing is somewhere in the middle. Okay, it goes from least to greatest, at least when the inequality symbols are aligned like that. I'll remind you quickly of the inequality symbols, okay? When I have this, it means that what's on the left is less and what's on the right is greater. When I have this, it means that what's on the left is greater and what's on the right is less. It's commonly thought that these guys are actually little alligators, and they are preferring to eat the bigger meal, if you want to think about it that way, if that helps. There's also a twist on these guys. There's the less than or equal to symbol. Okay, so this says that this is less than, but it could also be equal to what is on the right, which is either greater than or equal to it. Okay, so for an example like that, I would be able to say that 3 is less than or equal to 4, but I would also be able to say that 4 is less than or equal to 4. Because of the or equal condition, both of these things are true. I cannot say that 4 is less than or equal to 3. Okay, that is not true. And it also has a counterpart that faces the other direction. There is a greater than or equal to sign. Okay, it says that the left is greater than or equal to whatever's on the right, which is definitely less than or equal. So just a quick reminder about how those work. Now, as they appear in expressions, they can be manipulated a lot like equations, okay? There's actually not a big difference. Well, there's one, I guess, big difference. I would call it a key difference that involved with solving things as if they're equal signs, getting a x by itself or something like that. But I do not think that's going to appear here. Actually, I take it back, it will. So we're going to be able to solve this, and that's how I'm going to solve this problem for you. I'm going to solve this expression for x. I am not going to plug in each of these to see which thing is true. Okay, I don't like that method. I think it would take a lot longer, and I'd rather have you be in the stronger position of being able to solve this. Okay? But for the record, you could plug in each of these numbers in for x, evaluate, simplify the little thing, and the middle component here, and decide if what you get is between 3 and 7. If it's greater than 3 but less than 7. If it is, then you can check it off. Okay, but not my preferred method of doing things. Instead, I'm going to write this out, give myself some space, and the first thing I notice, is this over 3, right? This scary looking fraction. And I am going to clear that out of the expression. I'm going to clear that out of the expression by multiplying every part of the expression by 3, okay? Working with a compound inequality is like working with an equation, but you kind of have two sides you need to worry about. Normally what you do to one side of an expression you do to the other. This time you've sort of got 3 things you're working with, okay? And you're just going to do the same thing to all 3 components. Now when I do this, it becomes 3 times 3, which is 9. Notably, 3 times this thing, but then divided by 3, you have to notice, cancels out the 3, okay? That's the best way of looking at that. Now it's 9 less than negative 2x plus 7 less than 21. The next thing I notice about our expression that I'd like to get to the point where x is by itself is I have a plus 7. Okay, I have a plus 7. Now I'd like to undo that by subtracting 7 from all sides. Subtracting 7 from all sides. That allows this to cancel out. 9 minus 7 is 2. And we have negative 2x left alone here. And 21 minus 7 is 14. Okay, important part now. I would like to remove the negative 2 from this x region here. Negative 2 is currently being multiplied by x, so the prudent thing to do would be to divide by negative 2 on all sides. That does cancel this out, and it creates a 1 there, but it also does something very important. Because I have divided by a negative number, also applies for multiplying a negative number, sort of across the boundaries of an inequality statement, any inequality statement, whether it's just one or it's a compound inequality like this, I must remember to flip the signs. Okay, I'm going to change the direction of the inequalities because I have divided by a negative number. The result here is that negative 1 is greater than x, 1x, which is greater than negative 7. And this is true enough. Negative 1 and negative 7 are things on opposite ends of x. X is between these two things, though you might be more comfortable with reading this from least to greatest. I can turn this around. I'm not doing an operation to it. I'm just looking at it from the other side. I'd rather personally see negative 7 is less than x is less than negative 1. There is no difference between these two. I did not do an operation. I just like to see least things on the left and greatest things on the right. Negative 1 is greater than negative 7, and x is between these two numbers. So, which of the following is actually between negative 7 and negative 1? Let's consider our number line, okay? We have negative 7. We have negative 1. If I was to visualize this, okay, I would use an open dot to represent that this is not an or equal to situation, okay? I can't include negative 7 and 1 in my solution because they don't belong there. But everything in between this kind of gets highlighted or bolded. Everything in between negative 7 and 1. Right, there are things like 0 out here that are not in the solution set, and there are things like negative 8 that are not in the solution set. But what is in the solution set? Well, things like negative 6, negative 5, negative 4, negative 3, and negative 2. Read negative 6, negative 4, negative 2. And that's it for the things in this list that sort of belong there. And that's how you solve a compound inequality. You do things to all sides rather than just both sides. And you remember to flip around the direction of your inequality when dividing or multiplying by a negative number. I'm just going to put it on the screen because I'm going to want you to take it down and remember it. Okay, it'll be very important on the GRE. Okay, for inequalities, flip the direction when multiplying or dividing by a negative number. Solving inequalities, that is what you must remember. Other than that, okay, these could have been equal signs, and the rules of algebra and getting x by itself would have been the same.